Digital Learning in North Reading Public Schools, Daniel Downs, and I'm here with Kathy Dasho, who's a digital learning specialist in North Reading, and we would like to show you our presentation from the MassCUE Spring Leadership Conference on robotics, creating a rubric for district success with robotics, and developing a buyer's guide so we can look at a variety of robotics platforms.
Okay.
So the district vision for robotics and digital learning computer science is that in K through 5, we have digital learning and computer science and robotics integrated and embedded within the curriculum and embedded within our digital learning block. In grades 6 through 8, digital literacy and computer science courses exist, and we have a robotics 1 and 2 course. We also have Robotics Club for middle school students since 2012. In grades 9 through 12, we've introduced the Robotics Academy course, which utilizes the VEX EDR platform. And in 2017, we've added an additional course, Robotics 2, which will use the Tetrix platform in 2018. We also have a first robotics team, which has gotten off the ground, and our Change Team Student Help Desk has been active with robotics since 2015. A deeper look into our goal setting. We look at language-based review of our DLCS standards and co-teaching in elementary for more enhanced instructional opportunities with computer science and robotics. We also have a district-wide development of robotics competencies to help scale student learning and curriculum alignment. You'll see part of those competencies within this presentation. We're going to continue to refine course sequences at all levels and review student skill sets and their appropriate mapping. Our process. Our process began with expanding the digital learning specialist position into all schools and having the embedded digital learning block. Digital literacy and computer science teaching positions in the middle school were created in 2012 and 13, and an additional position in 2015. The business department, which had the web page design course as its main technology offering, added the Robotics Academy course to its offerings, and within the year, the department has been renamed to Digital Learning and Entrepreneurship. This department plans to expand CS and STEAM-related courses and cross-list the departments with overarching standards and skills. So I'm going to turn to Kathy now, who's going to talk about some of the curriculum parts of robotics in the curriculum.
Okay, so why robotics in the curriculum? For one thing, robotics are very engaging and they are a great way of introducing programming into the curriculum. They also are very real world and they provide very useful skills in future employment, such as collaboration and problem solving. It's accessible for all students. Everybody can do something with the robotics. In terms of higher order skills, you have plenty of resources available on the internet for teachers. You have your Lego Mindstorms, you have VEX EDR and IQ. You have some simpler programmable robots for maybe the higher elementary, such as Sphero balls. And you also have some more expensive versions, such as the Now robot.
So I'm going to give a quick overview of our robotics competencies. So these have been developed over the past year, and what we're looking to basically do with the competencies is on the elementary, middle, and high school level is develop a set of sequences for students at those levels so that we, not dependent on platform, we can teach robotics core skills so that no matter what platform we use, we are still addressing topics such as robotics in everyday life, learning simulations and sequencing and patterns with robots, breaking programs into behaviors, and also working with student-specific skills around problem solving, building robots, the hardware components of robotics such as block coding, sensors, specific software control systems that come along with many of these platforms. What you'll see is that also within the middle school level, we're really focused on project management skills and also building student skills towards autonomous movement and programming for decision making, and also building a base in the iterative design process and always a core groundwork in teamwork and accountability. We love to focus in these areas and plan to assist students, especially at that middle school level, to improve their building skills with the robotics, improve their programming and design skill with the robotics, and also how they have a stronger understanding of the hardware and software components of a variety of different platforms. This is a description from our Robotics Academy course at the high school. The course is really focused on getting students to get started with the VEX EDR platform and how they can better meet the needs of going through an introduction to pseudocode, breaking programs into behaviors, and have an introduction to natural language programming. And one of their first intensive hands-on building robots for specific design challenges with VEX EDR, learning the wireless system configuration with VEX, as well as virtually controlling the robot and a range of challenges as you go through the course. And as you can see, there's a range of soft skills and programming skills built in within these competencies. I would suggest if you want to take a deeper look at these competencies, you can go to the link provided at the title slide of this presentation and take a look.
Okay, so in terms of robots and robot kit information, at the elementary level, you have a wide myriad of choices. You can start out for the very young, you have Lego B-Bots, which are a lot of fun, but introduce core programming concepts. As they get a little older, maybe in third and fourth, there's the Lego We Do, which actually this year I've noticed has a strong storytelling component to it. There are many other robots available, such as the Finch. Another model is called the Ozobots. They are really, really powerful, and we're going to show you a video on one of them in a minute. The Sphero is a lot of fun and also comes with programming abilities, and a student could put the app right on their phone. The Edison is a bit of a cheaper version, but it still has a lot of powerful programming capabilities with it. But again, it's not that expensive. As we get more into the middle high school realm, we have the Lego EV3, which gives you an opportunity. You can scale that, you can grow with that. It comes with block-based programming, which by itself is very powerful, but can also be text-based. Then we have what we're doing right now at the high school. You have VEX Robotics. Right now we're using EDR at the high school. The IQ is more geared for the middle school age group. And then we're finishing up our high school with an advanced course in Tetrix, which can also align with the Arduino platform. Okay. In terms of robotics objectives, we are allowing students to understand what is being taught, what they're going to be assessed on. There are many different challenges. In this photo here, the students are actually programming the robot using something called encoders to try to keep the robot going as straight as possible. The PVC pipes are there, and if a robot bumps into it, all is lost. Okay. All right, you want to set up a workflow throughout the classroom to make sure that time isn't wasted trying to find your parts. We have utilized bins, which are going to come up in a later slide, to organize everything if you don't have cabinets available. Here's an example of a B-bot, some examples of B-bots in the curriculum. There's accessories, mats, and Kinder logo is some activities for the younger kids. Here's an example of an actual B-bot lesson that we do use in our elementary schools. It's almost like a little maze where the robot has to follow the line. The Ozobot sample lesson, modeling animal habits and habitats. The Ozobot is very small but very powerful. In this video here, this is an example of a kindergarten lesson where the students actually had to build their own obstacle course. So they got the opportunity to build first. You let them pick from 4 to 5 of the materials in a makerspace that we have at the school to build the course. And then they program the Ozobot to follow the course. And it's pretty much color-coded. But at kindergarten, you can imagine the fun the students would have with this kind of challenge. This is just an example of just some more photos of the students building their courses. And as you can see here, underneath Ozzo Blockley coding blocks, they are very similar to Scratch, so extremely user-friendly. As we move on up from elementary into middle school, we have one of your choices could be the Lego EV3. It can be used for upper elementary. We've used it here at the middle school. If you had extra kits, you could indeed move them up to the high school level. It starts out with block programming, which can go from simple to complex, and it can be easily integrated into your curriculum. Okay, here are some other examples of challenges right from the Lego curriculum. So if you're a beginning teacher just getting into the robot pond, there are many examples here in the Lego curriculum that you can use. This is just a screenshot of what the block programming looks like. Again, it's pretty user-friendly. The kids take to it pretty quickly. You can indeed advance, though. If you have older kids, you can advance to text-based programming. Here's a sample, again from Lego, of an EV3 lesson, autonomous parking. Okay, and this is very real world, programming a robot to park itself. Okay, and this is just what the blocks would look like in terms of turning, in terms of backing up, and in terms of getting into the space. This is an example of what that program might look like with text-based programming using Robot C for EV3. Okay, so Robot C is text-based. So for older kids, they always feel more professional using text-based programming. And these are just some examples of some students utilizing the color sensor over on the left with an EV3 robot and basically using a touch sensor on the right.
And feel free to go back and check out these videos. You know, at the end of the presentation, we have the link to the presentation.
Mm-hmm. This is an example of, I run a robot club at the middle school, and we actually purchased a kit for the appropriate models. As you can see here on the left, there's a rocket right there. And basically this is a list, this is a kit that contains all the models for 7 to 8 different challenges that the kids can use the EV3 for to program, and it's all Mars-based. Okay, so not only do they learn the programming, they learn a little bit about mission to Mars and what that would entail. Here are some terrific teacher resources for those of you who are interested in where do I begin or where could I go for some professional development. These links here are very, very useful. Okay, especially the one for Tufts, which I think is coming up on the next slide. Also, the Georgetown University, Yes You Can, is a great way for beginning teachers how to integrate robotics into the curriculum. She's done a great job in that link. Okay, here's the Tufts Center for Engineering and Outreach, and sometimes they will run a free training on a Saturday that teachers can go to. You can get your hands right in there into the kits, just like the kids do, and she will give you challenges to do in a group, and you have a lot of fun, and it's a very worthwhile day. Here we have VexIQ versus or VexEDR. Okay, both use Robot C to program. VexIQ is geared more to the middle school level with more of a visual interface. It still has the text programming, but it's really text like strings that you basically click on and they fall into place. Just sort of like a more advanced version, a text-based version of Scratch. Okay, also, most of the pieces are a heavier plastic, as opposed to VexEDR, which we're currently using in our high school, which is, there's very few plastic, except on maybe some of the sensors. Everything's pretty much steel. Here is a slide of the Vex, Carnegie Mellon's, and RoboMatter's video trainers, which I do find very useful. We have the VexIQ version, Introduction to Programming, and then the VexEDR video trainer. They come complete with step-by-step videos, tons of challenges, and also assessments and rubrics. Okay, here's an example of some of the video trainer topics. how to control basic robot movements, sensors and how they work, intermediate concepts of programming. They talk about pseudocode. They give you examples. It really is a useful thing, especially if you're a beginning teacher. This is an example of how to use the VEX Cortex Video Trainer in class. Every teacher, of course, will probably utilize it to the best of their own abilities, but this is their example. Down the bottom here on the screen is some of the challenges that you can use, basketball drills and power levels with encoders. That's what a challenge looks like. After you get done showing them the video, practicing a program, they then are let loose on their own to perform one of the challenges in their group with the robot. And here's a summary of the VEX EDR unit topics and challenges with a timeline included with it.
We can skip it.
Okay, scope and sequence. I mean, that's just kind of like too detailed. Here's an example, a visual example of what VEX IQ programming looks like as opposed to the VEX EDR programming. Okay, so you can see on the top, the VEX IQ is basically just a little bit more simplistic, just a tad, a little bit easier. On the bottom is the VEX EDR, which is totally text-based. And here are some bins purchased at Walmart that we use in our robotics classroom to store the EDR robots and all their components that come with them, such as sensors, wires, you name it.
We got those because they have wheels and they're easily able to move from one location to another if we need to have students work in a different space in the room or at a different table, or as we adjust our space, we feel like we have a flexible option. We also put locks on them, to kind of also help keep things safe and locked up when no one was in the room.
Mm-hmm. Also because we have to share the room, so it's Here's an example of a VEX engineering notebook from a student. And every time we get done with a challenge, or even sometimes I'll give them an assignment to research something having to do with the robots, they will type it into their engineering notebook. This is a video showing a minefield challenge. Where is the robot? You have 30 seconds of autonomous behavior, and then I think 3 minutes of joystick behavior. Okay, here's another example of a VEX Sentry challenge using encoders, where they basically had a patrol, program the robot to go into a square around those PVC blocks, not knocking any down, obviously, using the encoders to control the distance. Here's an example of a midterm student video. They were charged with explaining what a Robot C program, what every line of code meant. Here's a VEX EDR work habit rubric. And here's an example of the engineering journal rubric from the video trainer.
Another tool we've used is Coder Z, which is a block-based robot simulation piece of software. We found that allowing students to use this software to be able to practice coding in both block-based and strict languages improves their coding and programming ability with the robots. So if you have a limited number of robots and you really want students to work on their programming skills, you can purchase Coder Z on a per account per student basis. We found it handy to enable students to practice coding, get used to coding interfaces, and then export their code to robots.
This is just an example again of how coders block coding is so similar to Scratch. The kids make the transition very easily. And this is an example of Tetrix programming, along with a link to the Tetrix classroom, so you can check it out. It's very much like Robotics.
I just want to thank you for sitting through, and thank Kathy for doing all the hard work she does in our district with robotics, and we look forward to continuing to improve and align our curriculum.
And if you have any questions or want to know anything specific about a specific platform, please feel free to get in touch with us via email, or you can always give us a call in North Reading.
And we'd love to share, so if you also want to take a visit, let us know. Thank you.
Thank you.